What is up? We are back. We are looking today at section 5.8. This is the final section of chapter 5. We are looking at solving equations by factoring. So, what do we do? Up to this point, we've been factoring expressions. Okay, we've been jumping in, and we haven't set any of our expressions equal to a number or to a value. We haven't really solved anything. All we've been doing is factoring. Now today we are going to step it up a notch, and we're going to solve equations using some cool features of factoring. So the big principle that we are going to look at specifically is the zero product principle. Okay, if I have two factors set equal to 0, then at least one of the factors is equal to 0. In other words, I have a times b equals 0. A and b are both variable expressions. Then either a is equal to 0 or b is equal to 0, or they're both equal to 0. So that's super complicated. Simplify. Okay. For example, if I have this, x plus 4, x minus 3 equal to 0, what I'm going to do is set them both equal to 0 separately. Okay? So to solve this problem, I set x plus 4 equal to 0, x minus 3 equal to 0. I solve separately. Over here, I'm going to subtract 4 from both sides. I find that x is equal to minus 4. Here, I'm going to add 3 to both sides, so I find that x is equal to positive 3. So when we are looking for solutions, these are two possible solutions for this problem. They're both solutions, okay? The thing that is important for us to remember is that we need to write equations in standard form, okay? I cannot solve this if the number is something else on this side. So if I say, for example, I put a 12 over here, you can't use that zero product principle. It only works when the one side of the equation is equal to 0. Zeros of a function, I don't know, mathematicians aren't the most clever people in the world when it comes to just naming stuff. So when you hear a question, find the zeros of the function, it's literally saying write the equation in standard form, then set it equal to 0 and solve. It's very, very not complicated, I guess, is the way you can think of it. So for example, if I say find the zeros of the function x squared plus 2x minus 15, basically I'm saying x squared plus 2x minus 15 equals 0. Okay? That's it. Solve for exactly the same thing that we did above. So you can go through this example here. Again, it's just something specific for your notes. I am going to jump into the whiteboard here, if I can pull it up. Nope, my whiteboard is turned off. Give me just 1 second. And boom, here we go. Okay, so now we are going to look at some problems. Question number 10. We'll start off easy, and we'll make it a little bit more difficult. They ask us, solve this. A minus 5, a minus 2 equals 0. Okay, so I am going to set each individual piece equal to 0 and then solve for that piece. So a minus 5 equals 0. I also have a minus 2 equals 0. Let's just do one at a time, and then we'll get down to our solutions and then write it out all nicely. So we add 5 to both sides. We're going to find a equal to positive 5. Add 2 to both sides. A is equal to positive 2. So these are our two solutions for this equation. So a is equal to 5 and a is equal to 2. Now one way that you may be asked to write this is to write it as a comma separated list, and if so, you can write it like this. You can do it from order from smallest to biggest or biggest to smallest. It shouldn't matter. I'll go from smallest to biggest just for the sake of it. A is equal to 2 and 5. Okay, That's a terrible 5. I don't know why I drew it like that. 5. Okay. A is equal to 2 comma 5. All right, so that's question 10. Question 14. Here we have 4a minus 1. A plus 9 is equal to 0. So now we need to go about solving this equation. Now the way to do it, again, same idea. 4a minus 1 equals 0, and a plus 9 equals 0. Okay? We'll add 1 to both sides here. Again, do both separately. 4a is equal to a positive 1. And now I can divide by 4 on both sides, and I find that a is equal to 1/4. Okay? Over on this side, I will subtract 9, and I'll find that a is equal to a minus 9. So my solution is going to be a equals minus 9 comma 1/4. So there we go. That's our final answer. Now, what about a situation where we have not factored, or we don't have the factored form given to us? We have to actually factor it. Oh man, we're ramping up difficulty. Here we go. Question 20. A squared minus 8a plus 16 is equal to 0. Okay. Let's think about all the combinations. So 1 and 16 can't give me an 8. 8 and 2 can't give me an 8. 4 and 4, which are factors of 16, can. So it looks like I'm going to have 4 and 4. Okay. So since this is positive and this is negative, both of these are going to be negative. So I'm going to have a minus 4 equals 0. Okay? Again, if you want to use the long method of writing the table out, finding factors of 16, you certainly can do that. I don't have a problem with that. I'm just going a little bit faster using some of the mental math that I showed a couple of sections ago. So now we set both equal to 0 and solve. And you're going to notice something. A is equal to 4. A is equal to 4. They're the same thing. That's totally fine. Sometimes you get double values. You don't have to write both down. So if it says, hey, show me the values in a comma-separated list, all you have to write is a is equal to 4. Okay? This is completely sufficient. So again, because it shows up twice, you only have to write it once. You don't need to write it 2 times. All right, so that is that particular problem. Let's go ahead and jump into question 34. This one is going to involve pretty much all of the rules and all the tricks that we've had to look at this entire chapter. So prepare yourself. Here it comes. Okay? 34. X times 2x minus 5 is equal to 12. All right, remember what I said. You cannot have a 12 on the right-hand side. This must always be a 0. It has to be a 0. So here's what I'm going to do, how I'm going to approach this problem. I'm going to multiply the left out, and then I'm going to bring the 12 over to the other side. So that way it's connected with all this stuff and I get a 0 on the other side. Then we're going to refactor it and then hopefully solve for each of those factors, setting it equal to 0. Okay, again, it's a multi-step process. Sometimes it's not like there's the problem, the solution is one step. This could take 5, maybe 6 steps, right? But again, logically you have to try to think through what are the processes. Okay, This has to equal 0, so that means that I have to move it to the other side. Well, if I move it to the other side, then I have to refactor it, and so on and so forth. Okay, I'm not going to walk through it. Well, let's just go through the problem so you can see how I would do it. So let's multiply this all out on the left. So this is going to be a 2x squared minus 5x is equal to a 12. Subtract 12 from both sides. You get 2x squared minus 5x minus 12 is equal to 0. 2 sections ago, do you remember we had situations like this? So a is equal to 2, c is equal to a minus 12. That means a times c is equal to a minus 24. Okay? Now, I am going to write out factors of 24. I might have to erase my whiteboard here, so I'm going to try to do it down here. Factors of 24. Okay. And the sum. Again, let's just do the table. Minus 1 and 24. I'm really afraid I'm going to run out of room here, so please bear in mind. I'm doing my very best. Minus 2, 12, 2, minus 12, minus 3 and 8, and then 3 and 8. I think it's going to be the very bottom one, I'll be honest. And of course, you can't see it. So, all right. So if I added all these up, this is going to be what? 23. This is going to be a minus 23. 12 and minus 2 is going to be 10, right? Minus 10. And then this bottom one is going to be a 5 and minus 5. Okay. Which, of course, it's going to be the bottom one, and you probably can't even see it because I'm at the very, very bottom. The factors are going to be minus 3 and 8, okay? Imagine I had the space. Let's just pretend that it is there. So our factors are going to be minus 3 and 8, but remember, when we have something that's like this, we have to factor it a little differently. So we're going to, let me come up here. Zoop. Sorry. 2x squared minus 3x plus 5x minus 12 is equal to 0. Okay? And now we do the brackets around the first piece and the second piece. Plus 5x minus 12 is equal to 0. And then we factor out from each of these individual pieces things that are in common. What? That's an 8. Sorry, 8, not 5. That must be an 8. My mistake. Okay, now we're fixed. I started with a 5, so that needed to be an 8. That was minus 3. Okay, we're good. Sorry. Rewind. So, now it looks like the only thing that's common between these two pieces is just an x. 2 and 3 don't have any common factors, so but x squared and x do. It's just going to be an x, and what's left is going to be this. And then over here, a 4. Yeah, 8 doesn't go into 12. Remember how I told you that trick? Divide it by 2, then multiply and see if it works. Divide 8 by 2, and that's going to be a 4. And 4 does go into 12. So pull 4 out. And what's remaining is going to be a 2x minus 3. How about that? Equals 0. Okay. So now when I factor this, I'm going to have x plus 4. Remember, I combine the individual pieces as long as these things here are the same. 2x minus 3 is equal to 0. And now, since I'm running out of space, I'm going to come back up here. I'm going to imagine that we have all of this sorted out. Okay. So we're going to do x plus 4 equal to 0, and then 2x minus 3 equals 0. Okay? And that is coming again from this piece over here. I set each individual factor equal to a 0. So subtract 4 from both sides, and I'm going to get x is equal to a minus 4. Add 3 to both sides here, and I get 2x is equal to 3. Divide both sides by 2, and x is equal to 3 halves. So here is one of my solutions. Here's my other solution. So if I wanted to rewrite it as a comma-separated list, I'll go minus 4 comma 3 halves. Okay. And now if you want, you can test it. You can take these values and then just toss them back into my very original equation, and you should get that. So let's just try it. Let's just do the minus 4. We've got a minus 4 here. 2 times minus 4 is a minus 8. Minus 8 minus 5, 8 is going to be a minus 13. Wait a minute, something is off. What did I do here? I feel like I made a mistake here, and I'm not sure what it was. I think I flipped the sign somewhere. I think that this is supposed to be a minus plus and that's supposed to be a minus. I definitely made a mistake somewhere. Okay, let me go back here. Oh. Okay. Sorry guys, here is the reason why. I'm ridiculous. This should be minus, this should be plus. Which means that this is going to be plus, this is going to be, yeah. Okay, all the signs got jacked up. Basically, you get down to the very end, and you just flip the signs, okay? Sorry, that was my mistake. If I substitute these numbers in, they should work. So 4 times 2 is 8. 8 minus 5 is going to be 3. 3 times 4 is going to equal 12. Okay, perfect. Now we're, okay, great. Yay. I'm so happy about that. This is the solution. I made a mistake here with the factoring. The signs basically just end up getting flipped. So this is a minus. This is going to be a plus. Okay. Oh, sorry about that. My awesome example just turned out to be such a mess. Let's do another one so I can hopefully redeem myself. I think I'll do 2 more. So let's take a look at question 44. So here we're given x cubed plus x squared minus 9x minus 9 is equal to 0. Okay. So this is going back a few sections, but we're going to rewrite it out. We're going to put brackets in front of the pieces. Now, interesting thing. If I pull a minus sign out in front of this bracket, this makes this a plus. Okay? Because if you distribute that minus sign, it makes that actually a minus. Like that. So if we're pulling a minus out of these 2 pieces, we have to change the sign of one of them. Okay? Alright, so now we factor from each of these individual pieces. So I can factor in x squared, and I'm going to be left with an x plus 1. Over here, I can factor out a 9, and I'm going to be left with an x plus 1 as well on the inside. The way you can test it is 9x, 9 times a 1 is going to be a positive. So there we go. And now I can merge my 2 pieces in front because these guys are the same. I have x squared minus 9, x plus 1 equals 0. And remember, this is from the last section. This is actually one of those special situations where it's a squared minus b squared is equal to a plus b, a minus b. Okay? So x squared minus 9 is going to be x minus 3, x plus 3. If you are unsure of that, do the process that we did the very last section using the a's and the b's, and you'll see that it's going to equal that. Okay. So now I've got x minus 3 equals 0, x plus 3 equals 0, and x plus 1 equals 0. So x is equal to, well, hang on. I will add 3 to both sides, subtract 3. Well, okay, again, I said do the whole thing, so let's just do it. X is equal to 3. Subtract 3. X is equal to a minus 3. And then subtract 1. X is equal to a minus 1. Okay. So these are all of your solutions down below at the very bottom of the whiteboard. Okay. So x is equal to minus 3, minus 1, positive 3. Okay. So that's question 44. I'm telling you, factoring, it's a big deal. It shows up all over the place. Okay, let's take a look at the last question, question number 60. 3x squared minus 7x minus 6 is equal to 0. And because I have a leading coefficient, that means that I'm going to do the a times c method. So a is equal to 3, c is equal to a minus 6. So a times c is equal to a minus 18. All right, let's do the factors of minus 18 and the sum right next to them. So let's do minus 1, 18. Wow, man, my writing is really bad today. 18. 1 minus 18, minus 2 and 9, 2 and minus 9, minus 3 and 6, 3 and minus 6. And I think that's it. I don't think there's anything else. So 18 minus 1 is going to be a 17. This is going to be a minus 17. 7 and minus 7, and I mean, I can tell you right now we're going to stop right there, but I'll just do this, why not? 3 minus 3. Okay, so this is the guy because it matches right here, which means these are our factors. So we are going to rewrite them, remember, as 3x squared minus 9x plus 2x minus 6 equals 0. Okay, so we're replacing them with the middle pieces. You can go either way, either order. It doesn't make a difference. You're still going to get the same solution. I just went this way because why not? You know, it was completely random, honestly, how I chose it. So, all right, so 3x squared minus 9x. Brackets in front of those pieces. Okay. Now we factor out what's common between both of these. So there's a 3 in both a 3 and a 9. There's an x in both an x squared and an x. So it looks like a 3x is coming out, and I'm going to be left with just an x for the first piece and a 3 for the last piece. And then over here, looks like it's only going to be a 2, so I think this is going to be plus 2 times x. 6 divided by 2 is going to be a 3. This is equal to 0. And now we can combine these two pieces in front because these guys are the same. So 3x plus 2 times x minus 3 is equal to 0. And now we will just solve them separately. Okay, so 3x plus 2 equals 0. x minus 3 equals 0. Subtract 2. 3x is equal to a minus 2. Divide by 3. X is equal to a minus 2/3. And then I'll do this side. Plus 3 on both sides, and I'm going to get x is equal to a positive 3. Okay? So my two solutions are going to be minus 2/3 and 3. So that is the solution to that particular problem. Okay? That's it. That's all we got. Like I said, it's there's a lot of kind of random problems, but if you really commit to understanding the rules of factoring, if you work through each section as I've gone through them to really understand it as best as you can, you should get through this content without too much of a problem. It may take a little bit of just effort and energy, maybe more than you're used to, but like I said, I really encourage you to really try to master this content as best as you absolutely can. Okay? So that is it. That's pretty much all we have for today. If you have any questions, let me know. Have a good one.